Welcome to Baba's channel. In this video, we'll discuss about FP16 BF16 in the large language model. In the large language model, default parameters set generally if you see while inference you are training BF16. So what is difference between BF16 and FP16 in the LLMs? We'll see in the detail. So both FP60 float 16 and BF16 B float 16 B float like brain floating point format that called as BF16. Both are 16-bit floating point format and both are used for reduce the memory uses in compared to FP32 floating point formats in compared to FP64 floating point format. And it's speed up GPU, TPU computations, and it's feasible to training for the massive data, yeah, big model also. Okay, let's take a one by one difference. For example, FP16. So, particularly each uh, FP16, yeah, BF16 total count of floating point is 16, but how they are different: 1 bit save for sine, 5 bit exponent, and 10 bit mantissa means fractions. And for FP16 difference here for 8 bit exponent for FP16 and 5 bit exponent for FP16. So difference here precision, right? This 5-bit exponent and 8-bit exponent difference make huge when you do inference. How will it will impact? Okay, what is 5-bit? What is like this exponent? Exponent means like uh, uh, how the number can be scaled. So here number scaling is only 5-bit exponent. Here number scaling 8-bit exponent. That is mean BF16 8-bit exponent, it can handle large number also. So in GPU there are problem if you training if your number overflow or underflow. If if your limit is only 5-bit, if number go beyond that, then overflow problem will happen and your training die. If 8-bit, it can handle more large number, yes, scale number while training also. So that is different. That is difference here. So okay, fraction. So fraction will give more, more precision, but bit exponent will give you stable training. So okay, here you compromise with precision, but your training would be the stable, and you can save your model, your training pipeline by overflow and underflow of the numbers. Okay, I'll take other parameter also. There is difference. Difference is here FP16 5 and here 8, that is exponent number. Mantissa difference also. So like fractions also. Fraction is good here due to this fraction uh, floating point bit is good number, 10 number here lesser number. That is why precision is very higher for this one. Good precision and lower for this one. But overflow underflow risk is very high. And here the risk is very low. Then here stable training is very stable and most commonly used. So that is the advantage here. Okay, so okay, now we know mathematically how BF16 and FP16 is difference. Now we want to know how it will impact to the model. Why does this matter for the LLM? And what advantage of BF16 if you use for training at all? Little difference I already told, but in more deeper detail, like whenever like you activate especially while training like gradient and activations can be hook, yeah, can be high. If very hook and number exploit it beyond 5-bit exponent, then your model die. So that is matter here. So activations might be hook, yeah, tiny. If number format can't represent them, then problem is overflow, yeah, underflow. Overflow means it's beyond 5-bit. Underflow means less than 0. So what will happen is your training is break the training. So you want to do stable training, then you need this. So advantage is BF16 give exponent bit good number, exponent bit same as FP32. So if you want to train with the FP32, same exponent number given by the BF16 also. So your training is stable. So that's why, and most of the modern hardware, so hardware also need to be support this kind of combination. So all modern NVIDIA A100 GPUs, yeah, post it all supported that. Old also few supportive. So we need to check the GPU configurations where first we want to train the model is BF16 is already supported or not. So the basic fundamental of BF16 and FP16. Very soon I will come with how you train your scratch tiny LLM for your personal use. I will go through that. Few things I will talk in the few videos related to how GPU memory, GPU optimizations, how you utilize the GPU and setup of the GPU and everything. Then we'll go for build your tiny LLMs. Thank you so much for watching. Keep be subscribed for next video. Thank you.